Hello everybody. Today we're going to be looking at multi-step equations. So a good video to watch prior to this is obviously your one-step equations and then two-step equations. And this is just going to build upon that. So you really want to make sure that you have your integer rules hammered down for adding, subtracting, multiplying, and dividing. One thing I definitely suggest with this is that you really want to be concise with your work and organized. Otherwise, like one little mistake could really ruin the whole problem. But it's pretty straightforward. You may want to watch the video a couple times to get it, to understand it fully. Please be sure to like the video if you do, and subscribing would definitely help me out. So enjoy. So let's take a look at two basic multi-step equation problems. So we're looking at it where our variables are only on one side. That'll be a future lesson where we have variables on both sides. So we highlight this and this. So it's like combining like terms, which we did in a previous video. We notice that the signs are different, so we'll actually subtract. So we get 28x. It remains negative because this number here is larger. All right, so those guys are out. We'll bring down what's left. Right now, what we're going to do is, it's now just a simple two-step equation. We're going to add 18 to both sides. Right, we get a result of 56. Right, so this is done. We can bring down what was left over here. Right, and as I said in the previous video, your multiplying and dividing typically should always go last. So we're going to divide by 28. Remember, we're keeping it negative 28. All right. So since the signs are different, if we remember the party hat rule that we talked about with multiplying and dividing integers, it's going to be a negative result. 28 goes into 56 two times, so negative 2 was our answer. All right, now this one's a little bit different because we have these parentheses. So what we need to do is distribute the 4 to both the variable and the number inside. So 4c, we don't know what the c is, so we just simply rewrite it just as that, 4c. 4 times, well, this is actually a negative 3, so it's 4 times negative 3, which is a negative 12, minus 6 equals 10. Now, whereas before we could combine the coefficients and variables, now we can combine these constants. So there's nothing for the 4c to combine with. Negative 12 and negative 6. Remember, go back to our lesson on adding and subtracting integers. That gives you a result of negative 18. We bring down what's left, and now it's starting to look like a two-step equation, so we'll simply add 18 to both sides to get rid of the 18. So we have 4c equals 28, which I'll rewrite over here. And it's all positive numbers, so there's not really many rules to remember. We divide by 4, and c equals 7. Okay, so this particular problem is much different from what we saw before because now we're dealing with this denominator of 7. All right, so we want to somehow get rid of the 7. Well, technically this is a fraction, but it also works as a division problem. So we're going to multiply by 7, but if we do it to that side, we do it to this side as well. So now we're left with 0.4n minus 1 equals 35. All right. Now, once again, it looks like a two-step equation. We'll add 1 to both sides because we want to isolate that variable. So 0.4n equals 36. And it looks like if we divide by 0.4, right, let's remember that our bottom number goes on the outside. And with our rules of decimals and division, we can't have a decimal on the outside. So we slide once here. And our decimal is right here. We just don't see it. Slide once here, put it in a 0. 4 goes into 36 9 times. We still have the 0 to worry about, so our final answer would be 90. All right, so let's take a look at this problem. Definitely a larger, more difficult problem than some of the videos we've seen before, but very typical of a standardized test type of question. All right, let's read through. It says there are 5 times as many tomato plants as there are cucumber plants. The number of pepper plants is 7 more than the sum of the number of tomato and cucumber plants. There are 19 pepper plants in the garden. How many cucumber plants are there? All right, so in this little section here, and we'll do this on another slide as well, is we're going to write down what we know. There are 5 times as many tomato plants as there are cucumber plants. All right, so what that means is if there's 5 times as many tomato plants as there are cucumber, we would have to multiply the cucumber plants, which we'll list as C, 5 times for it to be equivalent to the tomato plants. All right, so that's all from here. All right, and then on another color, I'll do something different here. All right, then the next part, the number of pepper plants, all right, so P is, remember, is means equals, is 7 more, so 7 plus the sum of the tomato and cucumber plants, so T plus C. All right, then it states, oops, so let's go back. All right, so that's for this one here. Yeah, all here, this is all for this. All right, and then in light blue, we'll say there are 19 pepper plants, so P equals 19. All right, so you may want to take a shot of this because we're going to do this on another slide. But that's all the information we need to find out how many cucumber plants there are and how many pepper plants. All right, so let's take a look. We'll move to a different slide here. All right, so let's write this down again. We have 5C equals T. 7 plus T plus C. Remember, T represents tomatoes, C equals cucumbers, equals P, our peppers. And we know that exactly peppers is 19. So we're going to use this right here as our main problem, right? So P, well, we know that it equals 19. We got that from here. T can now be replaced with 5C. All right? So now we can combine these like terms, giving us 6C equaling 19. And then we can solve. Minus 7, minus 7. So 6C equals 12. We divide by 6. So our cucumber amount is 2. Now we can go back and substitute. So if C equals 2, we do 5 times 2, equaling T. Well, then our tomato count would equal 10. And we already know that our peppers are 19. Much more of a difficult problem, but just kind of take it slow and rip it apart a bit, all right? So you might want to go back and rewatch that one a couple times. All right, so that was our lesson on multi-step equations. As I clarified through the video, we're only looking at combining like terms on one side. We're eventually going to see variables on both the left and right of the equal sign, which is, that's probably the climax or the pinnacle of what we could do with solving equations. All right, granted, we haven't looked at exponents or anything like that yet. So definitely a very important lesson. I definitely think that word problem that we did at the end, I've seen that come up multiple times, even as a teacher testing to get my practice. That's a very typical problem. But the way we broke it down, I think, was very useful. So leave a comment. Be sure to subscribe. I hope you enjoy it. Take care.